Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter uh, moving charges and magnetism. So any doubts if you have, then please write that in the comments. Okay. So here it has been told that a galvanometer of resistance 50 ohm is connected to a battery of 3 volts along with a resistance. So here we have a galvanometer. It has resistance G which is 50 ohm and it is connected in series with another resistance R1 which is 2950 ohm, and it is connected with a battery of 3 volts. Connected with a battery of 3 volts. And here we see that it shows a full scale deflection of 30 divisions. So let's say the current which flows through it is I. So this current shows full scale deflection. So the current which is flowing, that will be obviously 3 by G plus R, that is 3000, 3 by 3000 ampere. So which is point 1 by 1000, so 0.001 ampere, or you can say 1 milliampere. So 1 milliampere shows full scale deflection. Then it has been told that in order to reduce the deflection, so it shows full scale deflection of 30 divisions. So now here it is told how much should be the resistance connected in series, that is R should be how much, so that it shows a deflection of 20 divisions only. It shows a deflection of 20 divisions. So the same battery is connected. So and G is equal to 50. So here, let's say I call it the current, here it is I1. So then I1 will be equal to 3 by G plus R. G is 50, 50 plus R. And that should be equal, so 30 divisions deflection correspond to 1 milliampere. So 20 divisions will correspond to um, 20 by 30 milliampere. So 2 by 3 milliampere. So 2 by 3 milliamperes current should flow. So it will be 2 by 3 into 10 power minus 3. Then R should be how much? So therefore we can see that this will be 3 by 50 plus R, that is 50 plus R. 3 by 50 plus R, that will be equal to 2 by 3000. This 9000, that will be equal to 100 plus 2R. So it means 2R, that will be equal to 8900. So therefore the resistance should be connected in series is 8900 divided by 2, that is 2 4 is 8, 4 is 8, 5 is 10, 4450 ohm. So option C is the correct answer. Then here it is told that a circular wire of radius R, there is a circular wire, it has got n turns and its radius is R and it carries a current I. The magnetic induction D at a point on the axis of the coil at a distance root 3r from its center. So from its center at a distance, so at the point P, which is at a distance of root 3r, how much will be the magnetic induction here? So how much will be the net magnetic field here? So here the magnetic field at any point on the axis, let's say if it is at a distance of x from the center, then B is given as mu naught ni r square by 2 into r square plus x square whole power 3 by 2. So this will be equal to, so here r is the radius is r only, but here x is equal to root 3r. Therefore, x square will be equal to 3r square. Therefore, this will be mu naught ni r square divided by 2 into r square plus 3r square whole power 3 by 2. So this will be mu naught ni r square by 2 into, this will be 4r square. So 4r square square root is 2r. So 2r whole cube. So this will be equal to mu naught ni r square divided by 2, 4 to the 8, 8 to the 16, 16 r cube. So r square r cube, this will cancel. So this will come mu naught ni by 16r. So option A is the correct answer. Then here it is told proton, a proton, so its charge is Q is equal to plus E, where E is equal to 1.6 into 10 power minus 19 coulomb. So it moves with a velocity. It is moving with a velocity V, which is yeah, moving with a velocity 5 into 10 power 6 G cap meter per second. Meter per second. Then it means that it is moving along the y-axis and through a uniform electric field. So the electric field acting is 4 into 10 power 6 into 2 I cap plus 0.2 J cap plus 0.1 K cap volt per meter. And the magnetic field B, that is equal to 0.2 into I cap plus 0.2 J cap plus K cap Tesla. So therefore, the approximate net force acting on the proton, the net force acting on the proton, that will be given as, so it will be QE, that is the electric force plus the magnetic force, which is QV cross B. Sorry, Q is not a vector. Okay. So this will be Q into V cross B. Now V cross B that we have to find. So now, therefore it means we have to find J cap cross J cap. I have to do cross product with I cap plus 0.2 J cap plus K cap. Then it will come J cross I. We know that I J K. The rule is that I cross J is K and J cross I is minus K. So this will be minus K cap and J cross J will be 0 and J cross K will be equal to I. So it will be plus I cap. So it will be I cap minus K cap. Therefore, the approximate net force. So we have to find the magnitude of this net force. Therefore, the net force on the proton, that is equal to Q, which is it is equal to E only. It is E into E plus V cross B. So it will be E into E, which is the electric field, that is 4 into 10 power 6 plus, no, 4 into 10 power 6 into, this will be 2 I cap plus 0.2 J cap plus 0.1 K cap plus V cross B, that will be 5 into 10 power 6 into I cap minus K cap. 5 into 10 power 6 into I cap minus K cap. Okay. Into 0.2 is also there. V cross B, if I do here, 0.2 also will be multiplied. So in this into 0.2, which is 0. So therefore, this will be E, which is 1.6 into 10 power minus 19. Into this will come be I cap into be 8 into 10 power 6 plus this will be from here plus 5 to the 10, so it will be plus 10 power 6. Then plus this will be 0.8, 0.8 into 10 power 6 j cap, and this will be plus 0.4 into 10 power 6 minus 10 power 6 to k cap. So from here we can take 10 power 6 as common outside. So this will be 1.6 into 10 power minus 19 into 10 power 6 into this will be I cap. So it will be 9 I cap. This will be plus 0.8 j cap, and this will be, so 1 minus 0.4 is 0.6, so it will be minus 0.6 k cap. So this will be 1.6 into 10 power minus 13 into this will be 9 I cap plus 0.8 j cap minus 0.6 k cap. Therefore, the magnitude of the net force, the approximate net force, the magnitude of the net force on the proton that we have to find. So it will be 1.6 into 10 power minus 13 into this will be square root of 9 square plus 0.8 square plus 0.6 square. Now 0.8 square, so this is 0.64 plus 0.36. So this will be 10, yeah, 36 will see 9, this will be 1. So 9 square, 81 plus 1. This will be 82. So 1.6 into root 82 to 10 power minus 13. This much Newton approximately. So root over 82 is approximately 9 only. So 1.6 into 9, and say 6 9s are 54, 9 1s are 9, 14.4 approx, 14. Yeah. So approximately it is 14.4 into 10 power minus 13, approximately this much Newton. So here it means that none of the options are correct. None of the options are corrected. Then here it has been told that a solenoid of length, a solenoid is there which is of length 50 centimeter, and it is having turns. Okay, the number of turns is 100 turns, and it carries a current I. It carries a current I which is 2.5 ampere. Then the magnetic field at one end of the solenoid, at the end we have to find. So we know that at the center on the axis, the magnetic field is equal to mu naught into Ni, where N is number of turns per unit length. So it will be mu naught into N by L into I. So it will be at the center. It will be the magnetic field at the center. But here we have to find the magnetic field at one end. So the magnetic field at one end, that will be equal to half of this, mu naught Ni by 2. So this will be mu naught by 2 N by L to I. This you have to find. So mu naught is 4 pi to 10 power minus 7 divided by 2 into N is 100 turns, and the length we have to take it in meters, means in the SI unit. So 50 centimeter is 0.5 meter. So 0.5, so it is half meter into I. I current is 2.5 ampere. So this much Tesla it will come. So therefore 2 and 2 will cancel out, and 4 pi, 4 into 2.5 is 10. So it is 10 pi, 10 pi into 10 power minus 7 into 100. So it is 10 power minus 5. So I can say it is like pi into 10 power minus 4 Tesla. So pi is 3.14. 3.14 into 10 power minus 4 Tesla. So option B is the correct answer. Then here it is told a current flows in a conductor from east to west. So we can say this is east, this is west, this is north, this is south. So it is in the horizontal plane. So it is the horizontal plane. So we can draw it actually like this. We can say this way it is north, this way it is south. And this one is upwards, this is downwards. Since why it is in the three-dimensional space. Since why this north, south, east, west, it is only along the horizontal plane. It is only along the horizontal plane. So now here it is told that there is a conductor. One conductor is there. Conductor, conductor. So here the current is flowing from east to west. Means like this. Current is flowing. The direction of the magnetic field at a point above the conductor here. At this point P, what will be the direction of the magnetic field? So as we know that the magnetic field will be formed in the form of concentric circles and which is centered around the wire. So if you use the right hand thumb rule, then we will see that the magnetic field will be formed. The direction will be like this. It will be anti-clockwise. If you see from this end, if you see from this end, then the direction of the magnetic field will be anti-clockwise. So it means at the point P, the magnetic field will be towards the north, towards the north. So option 1 is the correct answer. Then here it is told three long straight wires A, B, and C are carrying currents as shown in the figure. Then the resultant force on B is directed. Three long wires A, B, and C are carrying currents as shown in the figure. Then the resultant force. So here this is B. It is carrying 2 ampere current, and this where A is carrying 1 ampere current, and their separation is D. Where C is also carrying current 3 ampere. This separation is also D, and all of them are parallel currents. So we know that parallel currents will attract. Parallel currents will attract each other. Attract each other. So the resultant force on B it is arc. So the magnetic field due to B at the point A, that is inwards, and the magnetic field due to the where B at the where C, that will be outwards. So it means that if we do IL cross B, since we know that magnetic force is equal to IL cross B. So then if we apply right hand thumb rule, then the force, okay, we don't have to find, okay, We have to find how much is the magnetic field on the where B due to the where A. So it will be, if you apply right hand thumb rule, then it will be outwards. And the magnetic field on the where B due to the where C, that will be inwards. So it means the where B, the magnetic force on the where B due to the where A, be IL cross B, IL cross B. So it will be towards the where A, and the value will be, let's say the length of the where B is L. Length of the where B is L. So therefore, the magnetic force on the where B due to the where A, that will be towards the left, means towards the where A, and that will be I of the, means current in the where B, current in the where B, which is 2 ampere into L into B. B is the magnetic field on the at the where B due to the where A. B mu naught I by I is 1, I by 2, mu naught I by 2 pi r, so 2 by D. So this 2 and 2 will cancel, so it will come mu naught L by pi D. And then the magnetic force on the where B due to the where C, that will be obviously towards the where A, that is magnetic field on where B due to where C. So FBC, that will be equal to IL cross B. I is 2 ampere in the where A, and into L to B. B is again the magnetic field of the where C on the where B. So it will be mu naught I by mu naught into 3 by 2 pi D. So as we can see, it is coming 3 mu naught L by pi D. So therefore, this force is 3 times of this force. FBC, as we can see, it is 3 times of FBA. So it means the net force on the where B, the net force on the where B will be 2 times of FBA. So the net force on the where B, that will be equal to 2 mu naught L by pi D, and that will be towards the where C. The resultant force is directed towards C. Option 2 is the correct answer. Then here it is told electron of mass m and charge q is traveling with a speed v. It is traveling with a speed v along a circular path of radius r. Circular path of radius, that is r, small r, at right angles to a uniform magnetic field intensity. The uniform magnetic field B is acting outwards throughout the space. If the speed of the electron is doubled and the magnetic field is halved, the resulting path would have radius. So as we know that the radius of the circular path in a magnetic field, that is given as mv by qb. So here r, small r, is equal to mv by qb, and here it is told the speed is doubled. So v will now change to 2v, and the magnetic field is halved. It means b is changing to v to b by 2. The resulting path will have the radius. So here mass and charge is kept the same. So therefore the new radius, I can tell it r1, that will be equal to m into v, that is 2v, and q into b by 2. So it is coming 4 mv by qv. So which is equal to 4 times of the initial radius. So option 2 is the correct answer. The electrons in the beam of a television tube moves slowly from south to north. The vertical component of the magnetic field, Earth's magnetic field, points down. The electron is deflected towards. So here actually what is happening, we can take this is uh, so this is east, west, and this is north, this is south. And there is a vertical component of the magnetic field. So the it points downwards, BH. No, it is BV actually, the vertical component of the magnetic field. The electron is deflected towards. So here, uh, the electron is deflected towards. So here it is told the electrons are flowing the the television tube, the beam of a television tube move horizontally from south to north. It is moving from south to north. These are the electrons. So now magnetic field is pointing vertically downwards. So the magnetic force that will be equal to QV cross B. So the velocity is towards the north and electron is having negative charge. So it will be, you can tell it will be minus E into V vector. We can say suppose this one is, so if we apply the right hand thumb rule, then V cross B, V is like this and B is like this. So V cross B, V cross B will come towards west only. But since it is an electron, it is having negative charge. So it will be EVB into, it will be towards the east. Towards the east. The net force will be towards the east. So the electron will be now deflected towards the east. So option 3 is the correct answer. Then here it is told 3 long straight and parallel wires carrying current are arranged as shown in the figure. The force experienced by a 25 centimeter length of the wire C is. Force experienced by a 25 centimeter. Okay, so here we have wire D, and this is where C, and this one is where G. Current is flowing in the opposite. So they are anti-parallel currents. D and G are parallel currents, but D and C are anti-parallel, and C and G are also anti-parallel currents. So we know that anti-parallel currents will repel each other. Anti-parallel currents always repel each other. And this is 3 centimeter distance in between D and C. And similarly, the distance in between D and in between C and G is 2 centimeter. The current flowing in the wire D is 30 ampere, current flowing in wire C is 10 ampere, and current flowing in wire G is 20 ampere. So we have to find the force experienced by 25 centimeter length of the wire C. So the force will be obviously the net force acting on wire C due to wire D, that we have to find FCD. So FCD will be equal to I, the current in the wire C, into L, length of the wire C, into B. Means the magnetic field on the wire C due to the wire D, that we have to find. So that will be 10 ampere into length is 25 centimeters. So 25 centimeter means 0.25 meter. This will be 0.25 meter into the magnetic field on the wire D due to wire C. So that will be mu naught I by mu naught I, that is 30 by 2 pi D. It will be 2 pi into 3 centimeter. 3 centimeter means 0.03 meter. So therefore it is coming. So mu naught by 2 pi, that is so mu naught by pi, that is 2 into 2 into 10 power minus 7 into here we have 300 into 25 by 3. So 300. So that is 2 into 25, that is 50. So I can write 5 into 10 power minus 7 plus 3. So minus 4 Newton per this much Newton FCD, and which will be, there will be repulsion actually. Since why here the magnetic field at the point C due to the wire D, that will be inwards. So it will be I L cross B. So it will be it will repel the wire C. The wire D will not attract the wire C, it will repel the wire C. So this is wrong actually. So the wire C will be repelled by the wire D by the force FCD, which is how much? 5 into 10 power minus 4 Newton. And similarly, the wire G also will repel the wire C. So the force on the wire C due to the wire G, FCG, that we have to find. So that will be also equal to I, the current in the wire C, into the length of the wire C, into the magnetic field on the wire C due to the wire G. So that will be also equal to 10 ampere into 0.25 meter into magnetic field on the wire C due to the wire G. So that will be mu naught I, that is 20 by 2 pi to R, which is 2 centimeters, so 0.02 meter. So therefore this will come mu naught by 2 pi is 2 into 10 power minus 7 into, this will be 20 into 10, that is 200 into, this will be 25 by 2. So this will be 100, and 25 into 2, that is 50, 50 into 100, so 5000. So this will be also again 5 into 10 power minus 4 Newton. So FCG and FCD, they are magnitude wise, they are same. So they will just cancel. So the net force on the wire C, that will be 0. So option 3 is the correct answer. Then here it is told an electric field of, there is an electric field of, this magnitude is 1500 volt per meter, and a magnetic field, yeah, so it means the electron should be moving at right angles with the electric field, is having speed v, and the magnetic field is acting at an angle, so they all should be mutually perpendicular. The magnetic field is when as its magnitude wise, it is equal to 0.4 Weber per meter square, or you can say 0.4 Tesla also. So then this the uniform, the minimum uniform speed along a straight line the electron could have. So it means here also the magnetic force will be equal and opposite to the on a moving electron. So it means this way we will have the electric field and this way we will have the magnetic field on the electron. So they should be equal and opposite, then only the net force will be zero. So here also we can say that Fm that is equal to Fe, the magnetic force is equal to EVP, and that will be equal to E into E. So the speed of the electron that will be equal to V equals to E by B. So E is equal to 1500 volt per meter divided by B, that is 0.4 Tesla. So it will be 15,000 divided by 4. So this will be equal to 150 into 100 by 4, that is 25. 100 by 4 is 25. So then 0, 15 5s are 75. 15 5s are 75. We have 30, so 3750 meter per second, or I can say 3.75 into 10 power 3 meter per second. So option 3 is the correct answer. Then here it is told a proton and an alpha particle. Here we have a proton and here we have an particle, alpha particle. They are moving with the same velocity v. They enter a uniform magnetic field. They enter a region of uniform magnetic field. The uniform magnetic field B is suppose outwards. So we know that the charge of the proton that is equal to plus E, and its mass I can take it mass of the proton, let's say it is m. Similarly, the alpha particle, it will have charge plus 2e, and its mass of the alpha particle is 4m. So it enters a uniform magnetic field B, suppose, with their velocities perpendicular to the magnetic field. The ratio of the radii of the circular paths is. So the radius of the proton, so the proton will also move in a circular path, and the alpha particle will also move in a circular path. So the radius of the proton, so we have to find the ratio of the radii of the circular path. So it means we have to find radius of the proton is to the radius of the alpha particle, that we have to find. Now the radius of the circular path for the proton, radius of the circular path for the proton, that will be mv by qb. So mp into v by qp into b. So this will be mp, that is mv by eb. And similarly, radius of the alpha particle, that will be mass of the alpha particle into v by charge of the alpha particle into b. So that will be 4m v by 2eb. So this will be 2mv by eb. So it means the ratio will be 1:2. Since why? The radius of the alpha particle is twice of the radius of proton. 1:2. So option B is the correct answer. Then here it is told a positively charged particle of mass m is passed through a velocity selector. It moves horizontally rightward without deviation from without deviation along the line y equals to 2mv by qb with a speed v. So it means what here? Okay, it moves rightward without deviation along the line. Okay, it is not deviating. So here at this point, the value of y is, so it lies on the y-axis. So the coordinates of this point A, we can say it is 0, comma 0, comma 2 mv by qb, and the magnetic field is B, which is uniform. The electric field is vertically downwards. It is a positive charge also. It means what? If QE, here we can say that QE that should be equal to QV cross B. Means QV cross B will act upwards here. So QVB. Now the electric field is switched off at t equal to 0. The angular momentum of the charged particle about the origin at t equal to pi m by qb. Now electric field is switched off at t equal to 0, so it will move in a circular path only. So here, from here we can see that v is equal to e by b only, since why it is moving in a straight path when the electric field is not switched off. So if the electric field is switched off, then it will move in a circular path. Then R will be equal to mv by qb. So then the time period of revolution, we know it will be, so we know that omega equals to qb by m. Since why we know that m omega square r, that, or we can say mv square by r, that would be equal to qvb. So v is equal to, so v by r is omega, so omega is qb by m, and which is equal to 2 pi by t, where t is the time period of revolution. So t will be equal to 2 pi m by qb. So at pi m by qb, it will reach, so it will complete half circle. Will complete half circle. So it means that radius is mv by qb. So its diameter is 2, is so it means the diameter will be 2 mv by qb. So it means that at t equals to t by 2, which is half of the time period of revolution, which is pi m by qb, it will simply reach the origin, and the velocity will be towards the left. Same velocity v will come towards the left. Now the angular momentum of the charged particle about the origin, angular momentum L about the origin, that will be r perpendicular into p, which is r perpendicular into mv. So now the r perpendicular value will be 0 only. Since why? It is at the origin, it is its momentum or its velocity is at the origin only. So the angular momentum about the origin will be 0. So option A is the correct answer. So here it is told that a charged particle is subjected to acceleration in a cyclotron. The charged particle undergoes increase in its speed at which region? So inside the D's, there is no change in momentum, but here one oscillating electric field source have been put here, which is one AC source, and AC voltage source is connected here. AC voltage source is connected, so it will accelerate. So so the increase in the speed happens only in the region in between the T's. In the gap, inside the gap only, the speed will increase. Since the electric field is acting in between the D's only. Since the electric field, the oscillating electric field, here we have the oscillating electric field is acting in the gap in the D's, between the D's, in between the D's, D1 and D2. So inside the D's, there is no electric field. So inside the D's, there is no increase in the speed. So only in the gap in between D1 and D2, there will be an increase in the speed. So option C is the correct answer. Then here it is told a vertical circular coil, a vertical circular coil of radius 0.1 meter and having 10 turns, carries a steady current I. When the plane of the coil is normal to the magnetic meridian, a neutral point is observed at the center of the coil. If the horizontal component of the magnetic field, the horizontal component of the magnetic field is 0.314 to 10 power minus 4 Tesla, so then the current in the coil is. So it means there will be an opposite magnetic field uh, due to the current in the coil. So that we can tell it as B1. So it will be mu naught Ni by 2R. Mu naught Ni by 2R. And since at the center we have neutral point, so the net magnetic field at the center, that should be 0. That should be 0 only. Since here it is told that at the center we have a neutral point. So therefore the horizontal component of magnetic field will be equal to the magnetic field due to the current in the coil. So BH will be equal to B1. So therefore mu naught Ni by 2R, that should be equal to BH. So now mu naught by 2, that will be obviously equal to 2 pi into 10 power minus 7 into n. N is 10. I we have to find out. Divided by R. R is 0.1 meter is equal to BH. So 0.314 into 10 by 10 power minus 4. Now 0.314, I can say it is approximately pi by 10. So this will be equal to, so 0.1, so 1 by 10, that 10 will go up. So it will be 200 pi to 10 power minus 7 into I. That is equal to pi by 10. So pi into 10 power minus 5. So pi and pi will get cancelled. So I will be equal to 10 power minus 5 divided by 2 into 10 power minus 5. So this will be half. Half, so that will be 0.5 ampere. So 0.5 ampere current should flow through in the circular coil. So option 3 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter moving charges and magnetism. Still, any doubts if you have, then please write that in the comments section. And also install our Sapience education application, where we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone